Welcome to Design Thinking and Prototyping. There are some learning objectives that we would like to go over with you. By the end of this lesson, we will have covered the following topics. First, we will define the engineering design process and understand what the purpose of each step is. Next, we will identify whether a phenomenon, event, or idea is part of the problem or part of the parameter. We will also be looking at how design thinking is applied to different situations to facilitate problem solving and go into a deep dive on what makes design thinking a powerful tool for burgeoning inventors and innovators. Lastly, we will establish an understanding of the different stages of product prototyping process. Let's get started. The engineering process is a common series of steps that engineers and designers use in creating functional products. The process is highly iterative. This means that some of the steps of the process often need to be repeated many times before the next step or stage can be started. The engineering process is similar to the more well-known scientific method, which is an empirical way of testing ideas or hypotheses about the natural world through controlled experiments. The engineering process is a decision-making process in which fundamental and technical skills are applied to utilize time and materials efficiently to meet a previously defined objective or goal. The process helps engineers and designers optimize resources to solve a problem. Let's take a closer look at the basic steps of the engineering process. The engineering process have the following steps. First, a problem is defined, and then research is conducted into identifying the requirements of what the solution might entail. Next, engineers and designers brainstorm potential answers or solutions to what was laid out in steps 1 and 2 and 3. As a result of the brainstorming session, an idea is isolated for testing. This idea is often made into a prototype, which you can think of as a preliminary model. We will talk more about prototypes later on. This prototype is then put through a series of tests to ascertain whether or not it fulfills the requirements of a complete solution. Finally, the results of the tests are analyzed, and from this data, the idea for a solution is modified, refined, and made into a newer and hopefully better prototype for testing again. This process is repeated until the proposed solution meets all of the requirements and solves the defined problem. The fundamental elements of the design process are the establishment of objectives and criteria, research and analysis, clarification of objectives, brainstorming and ideation, testing and evaluation, and repeating the final 2 steps until a good solution is found. You may encounter slightly different variations of these steps. This is because this should be used as a guide for thinking about product development and not as strict rules. Albert Einstein famously said, "If I were given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute resolving it." So how do we define the problem? It is the first and probably most important step, since without it, no steps can come afterwards. In day-to-day activities, a problem rises where there is a need for something. Usually, end users are affected negatively because of the missing support. Another way to talk about this problem is a service gap or a market gap. Problems arise when there isn't an effective or accessible solution to address shortage or logistical issues in a particular workflow. Here we can define workflow simply as a way of getting something done, step by step, to achieve an end or a goal. A parameter can be a constraint or a boundary that must be followed when approaching solutions to a problem. Another way to think about a parameter is a limiting factor, such as cost and materials, just to name some common parameters. Keep in mind that design thinking will also involve economic analysis in order to come up with a solution that works within given parameters. Finding an idea for your engineering project requires you to identify the needs of yourself, another person, or a group of people. This act of looking at the world around you to identify these needs is called need finding. To help you find an idea for your engineering project, 1. Create a list of all the things that annoy or bother the people around you. Record this bug list in your design notebook. 2. Create a mind map of possible design problems, ideas, or areas of interest to you. Once you have found an idea for your engineering project, describe the problem by writing a problem statement. Your problem statement must answer 3 questions. What is the problem or need? Who has the problem or need? And why is it important to solve it? The format for writing a problem statement uses your answers to the questions and follows these guidelines. You can structure the thought as who needs what because why. If you're writing this down, you can also use the sentence form blank needs blank because blank. Once you have defined the problem, you can now use a powerful tool to move your process forward. Design thinking is an iterative process in which we seek to understand the user, challenge assumptions, and redefine problems in an attempt to identify alternative strategies and solutions that might not be instantly apparent with our initial level of understanding. At the same time, design thinking provides a solution-based approach to solving problems. It is a way of thinking and working, as well as a collection of hands-on methods. Design thinking is a process that encourages hands-on approach to creating innovative solutions. Engineers and designers use it to empathize with users, define users' needs, problems, and find insights to ideate solutions by challenging assumptions and creating ideas for innovation. Some of the world's leading brands, such as Apple, Google, Samsung, and GE, have rapidly adopted the design thinking approach, and design thinking is being taught at leading universities around the world now, including D School at Stanford, Harvard, and MIT. One question you may have is, what is the difference then between the engineering process and design thinking? After all, the processes seem to be very similar. Let me tell you, the main difference here is that engineering process relies on deductive reasoning, while design thinking relies on inductive or abductive reasoning. The other main difference is that the main agent, actors, inputs inherent in a design thinking problem are people who are unpredictable, irrational, and don't always do what they say. Keep this important distinction in mind so that you know which process you should use in which situations. A key component of design thinking and modern product development in a business market setting is user experience design. User experience design is also abbreviated as UXD, and the main idea of UXD and user research is that products should be customized to fit the needs of the users, and it shouldn't force users to adapt and change their behavior just to interact with the designed product. To set out to generate these facts, you must first gather data about your users through a structured approach. Typically, researchers begin with qualitative feedback, things that cannot be measured, like feelings, to discover users' needs and motivations. They might later test their results by using quantitative measures. UX researchers often focus on two sources of data, attitudinal and behavioral. Attitudinal is the cognitive aspects of our thought processes, mental state, and emotional reactions. Usually, there's a way to measure attitudinal data through surveys or user opinions. These are subjective reflections communicated through words. Behavioral research methods are different in that the focus is more on the actions of users. An easy way to remember this distinction is that attitudinal is what they say and behavioral is what they do. In some cases, the attitude and behavior are one and the same. However, be careful and always look out for situations in which the attitude is different from the behavior. These differences will give the product developer valuable insights into creating and designing a great product for customers and users. At this point, it should come as no surprise that good UX designers also have a really good understanding of human psychology. Psychology, anthropology, ethnography, and sociology are all important disciplines of UX researchers and good designers. It is easy to recognize good design rather than to define it. Don Norman, author of The Design of Everyday Things and commonly known as the godfather of design, famously said, "Good design is actually a lot harder to notice than poor design, in part because good designs fit our needs so well that the design is invisible." Good design might be easier to know through experience than explain with words. Here are some phrases from your users that will let you know that you have done the job right. I got what I needed. I didn't have to think too much. I really enjoyed using it. It's now become a habit of mine. I'm going to tell my friends and family and coworkers about this. But how do we elicit this kind of response from our users? The answer is by following the 3 U's. Designers can deliver high-quality products and experiences by having a thorough understanding of experience design. Usability, universality, and usefulness. Designers have to go beyond just user-friendliness and have a thorough understanding of the diverse community of potential users and pivot them as the center of the design hub. The product requirements and solution parameters should revolve around users. In order to further understand this, we will explore in depth the 3 U's of UX: usability, universality, and usefulness. Let's take a closer look. Universality is a concept that goes beyond specific differences of race, gender, culture, personalities, habits, etc. It points to commonalities that allows for a product to convert as many people as possible to end users. It's the idea that products should be designed to be radically inclusive. This is because at the end of the day, you want to design a product that can be used by as many people as possible. We can also say that this is the quality that involves or is shared by all people or things in the world within the scope of the problem we defined. Usability is defined by both qualitative and quantitative metrics. Some measurable data include time it takes the user to absorb the instructions on how to use, speed of using the product to accomplish the goal, how often mistakes are made, and how long can the user remember to use the product, and finally, how happy is the user after using the product. Usefulness is the most intuitive goal of design. It is simply whether or not the product has helped the user achieve their goal. Does this make the user's lives harder? If it does, then it's not useful. Products should be made to improve the quality of life for users and not add more steps to workflows, more pain points, and present bigger challenges. In those cases, the product has failed its purpose. Next, we are going to briefly talk about requirement analysis for product design and development. Requirement analysis originates from systems design, which is a subdiscipline under computer science and information architecture. It is the process of defining the expectations of the users for an application that is to be built or modified. It involves all the tasks that are conducted to identify the needs of different stakeholders. The success or failure of projects often depend on the preciseness or completeness of the list of requirements that the inventor, innovator, or developer can collect, compile, and archive. In the context of product development, requirement analysis helps us prioritize different targets at different stages of the prototyping process. Different levels of fidelities will be used to fit the needs and goals of that stage. Low fidelity will be used early on to test basic concepts and overall design, and high fidelity will be used to pitch to investors or as examples to head into manufacturing. It's important to keep in mind that most of the time will be spent testing specific features in the mid-fidelity range. Requirement analysis looks at design holistically from various stakeholders' perspective instead of only focusing on the customers. It can also be broken down into different steps and stages for greater clarity. This involves frequent communications with investors, manufacturers, and users to determine specific feature expectations. This also involves resolution of conflict or ambiguity in requirements as demanded by economics, production, and social or cultural factors. Does this sound familiar? It sounds a lot like parameters. Roughly, this process can be broken down to functional requirements, non-functional requirements, and user experience requirements. Functional requirements define the specific behavior that the system or product should support or facilitate. Non-functional requirements specify overall criteria without focusing on a specific aspect or feature. Some examples include hardware, software, reliability, etc. User experience requirements point to specific requirements that concern users who will be interacting with the system or product. Examples include interface, input, navigation, button presses, clicks, and more. In the world of design and prototyping, it is important to remember that sometimes a great solution to the wrong problem can be just as bad as not coming up with a solution at all. So be sure to always keep the requirements in mind of different stakeholders.